Hello once again, Taylor. This video is on lesson 109 of your math book, Corresponding Parts and Similar Figures. Okay, so let's go over some definitions. Remember what congruent is. I know you're saying it in your head. Right, it is when a shape or an object is the exact same size and the exact same shape. Now, you see on page 566 that you have two triangles. Those triangles are actually congruent to each other. Each triangle has three angles and three sides. The angles and sides of triangle ABC correspond to the angles and sides of triangle XYZ. That just means they are the same. They're the same length and they are the same size. So triangle or angle A corresponds to angle X. If you were to rotate angle ABC, you would see that it matches up completely with angle or triangle XYZ. So B corresponds to Y, C corresponds to Z. A line segment AB corresponds to line segment XY, and so forth. Okay, so if you look at example 1, those two triangles are congruent, and they want to know what is the perimeter of each. Well, you're actually missing a number. For the first triangle, you have something that looks like this. You have 3 inches and 4 inches, but you're missing the side. On the other triangle, you have 4 inches and 5 inches, and we already know that maybe that bottom side is 3. Well, let's go ahead and see. I want to make sure that this corresponds with the other triangle. So what I'm going to do is I'm just going to rotate it like this, and I get this. And so when you compare it to the other triangle, it is exactly the same. And we see that this long piece right here is 5 inches. So if you have 4 inches plus 5 inches plus 3 inches, the perimeter of this triangle is 12 inches. So that's how you figure out the missing parts to a line that is corresponding to each other, a shape that is corresponding to each other. Now the other one you see, down at the bottom, you see shapes that are similar to each other. Similar means that they have the same angle measurements, and they're actually congruent in the fact that they're the same. But they're a little bit different. One is bigger or one is smaller than the other one. They're not exactly the same size, but they're similar to each other. So if you look at triangle 1 and triangle 2, you see that those are not only similar, but they are congruent to each other. You compare triangle 1 to triangle 3, they're similar to each other. They're not the same size, but they actually do have the same measurements as in their angles. So if you were to shrink triangle 3, or if you were to enlarge triangle 1, they would be congruent to each other. If you look at triangle 5, you notice that if you were to shrink it, if you were to enlarge it, it would not match the other triangles. So triangle 5 is not similar to the other two triangles. Okay, or actually the other three triangles. Turn your page to page 568. Let's talk about example 2. It says two triangles below are similar. What is the measure of angle A? So in the first triangle you have angle A. If you were to rotate that triangle up and flip it, it would look exactly the same. So you would see that that triangle A point matches the top point of that second triangle. So your same measurements there would be 30 degrees, because that is similar to each other. Okay, the angles correspond to each other. So here are two important facts about similar polygons. The corresponding angles of similar polygons are congruent. So it doesn't matter how big or how small a polygon is, the angles are always going to be congruent to each other. Number 2, the corresponding sides of similar polygons are proportional. So this is where we got to get into some math portions of this. So if you look at rectangle ABCD and compare it to rectangle EFGH, BC is 4 centimeters, FG is 2 centimeters. Okay, so let's go ahead and compare. First of all, line AB and EF. So you put that as a fraction, as a proportion. Okay? AB is 2 to the 2 centimeters to the 1 centimeter of the other rectangle. Okay? Now the other side, BC is 4 centimeters to the 2 centimeters that are there. So these two fractions are proportionate to each other. They are the same to each other, only they're in a relationship. So what you want to do is you want to find the scale factor. The scale factor is just a number that tells you how much the proportionate grows. Okay, so you just look at this and you say, how many times can 2 over 1 go into 4 over 2? It can go into it 2 times, so your scale factor is 2. Okay, it is 2 times rectangle ABC is 2 times larger than rectangle EFGH. And that's how you find the scale factor. So the scale factor for that one is 2. Okay, review that a couple times so that you can really make sure that you understand how to find the scale factor of two similar polygons. Okay, the next thing I want you to do is work on practice set A through F and then watch the video to get your answers. I hope you have a great day, Taylor. See you later. Bye.